We now move on to consider the design issues involved in entity relationship modeling, or more precisely, the high-level design issues. When we discuss normalization, there are a very large number of design issues at a lower level. The first design issue that we must consider is entity sets versus attributes. For example, the instructor can be defined to have a phone number, or the instructor can be defined to have no phone number, salary, name, ID, but has a relationship, instructor phone, with a separate entity phone. And the question that you should probably ask yourself is the item under consideration best described with a noun or an adjective? So, attributes are descriptive properties of an entity. The phone number of the instructor is whatever it is. No different than if you talked about the hair color of an instructor or the eye color. By contrast, if we think of the phone as a separate entity and not as a descriptive property of the instructor, then it's a noun. It's an object in and of itself, and it has a relationship with the instructor. So let's consider the alternatives. The use of an attribute is always simpler. So loosely, one could say there is a preference for attributes over entity sets. If you can use an attribute, it will be simpler. The use of phone as an entity is going to be much more expressive, though. So a phone as an entity, we can talk about its location, we can talk about its type. It will, of course, have a number associated with it. This also allows us to have multiple phones per instructor very easily. Can we do that with attributes? Yes, we can. We could have, well, first of all, we could simply have a multi-valued attribute. But we could also do it with different phone types, cell phone, office phone, etc. It allows multiple instructors per phone also. Now, that might be slightly unusual, but suppose we were talking instead of instructors, students, and students were in graduate offices, and there were 3 students in a graduate office, or maybe 20 because they're housed in a shared lab facility, for example. Then having an attribute phone number would be probably undesirable because that will be repeated. Can we do that with attributes? I'll leave you to sit and think about that problem, and if you want to ask me during a tutorial session, during an interactive session, go right ahead and we can discuss it then. But for now, suffice it to say that a very easy way to handle multiple people per phone is to have a separate phone entity. Okay, what about entity sets versus relationship sets? So this particular situation, if you recall, the original diagram, the diagram of the university, had a student takes a course, and it had the attribute date. Sorry, not date, grade. I apologize for that one. Grade. So that was the original setup, and the proposal is to, instead of having that, to replace it with a separate registration entity. Now, that aspect of relationship sets having attributes, descriptive attributes, is in general a useful idea to keep in mind when deciding which to use. So first, though, let's consider, is the item under consideration best described with a verb or a noun? So, a student takes a course, takes winds up being the relation, and student and course are separate entities. Versus A student is registered, and registered students take a course. Now, this is what the textbook does. I personally hate this. This is the authors of the textbook having this overwhelming preference for binary relationships. There is a better alternative, and I would like you to keep this in mind, because almost always, if we are going from something like student takes course and descriptive attribute grade, if you are considering changing this such that we want this to become an entity, then the preferred solution is not to make two binary relations. The preferred solution almost always will be to say student is registered for a course. Actually, let me erase this bit so it's hidden, so we get it out of our way. We don't want this in our way. Okay. A student is registered for a course, and so there's a session. And to have this as a three-way relationship, okay? A student registers for. So we can think of it as A, and I'm going to, actually, I wonder if I can, a student registers actually bother for I want blue first, for a session or an offering, okay? And this is also an entity. The reason to think of it as a three-way interaction rather than two binary interactions is we have all of our student data, we have all of our session data, and the registration information is related to this. It is rarely the case that you would keep this separate. You would keep this separate in the context of, for example, a full-time student. So a full-time student, the student is registered. Okay. And within registration, you will have grades, etc. And then you have sessions. And in that context, you would probably have something like that, okay? And you would probably have something, not that, you would have something like that. So student registrations are then disconnected. That makes sense in the context of separate registrations from taking a course. A student who is registering for a course and it is a specific course, so they're not a full-time student, each course is registered for separately, you're better with a three-way relationship. So why do we decide which we would have? Well, does the relationship have multiple attributes? If you remember, when we had the notion of relationship sets taking attributes, I said it is preferable that there is a single attribute. If there are multiple attributes, it is better if they can be a compound attribute, even if it's just a kind of artificial name for a compound attribute. For example, when you purchase something, There's a date, a time, a location, and a quantity. Okay? Those can be seen as a single compound attribute with multiple values. If the student in taking a course has a grade and maybe there's other attributes, if those can be made into a single compound attribute, possibly multi-valued, okay, so for example, there may be separate assignments and quizzes, etc. If that can be made into a single multi-valued attribute of the relation, then it is probably okay. Assuming that single multi-valued attribute is only relevant to the relationship. If, on the other hand, the multiple attributes cannot reasonably be made into a single compound attribute, for example, registrations that's done for multiple separate courses, as in the case of a student who is full-time registered, are they paid up? Have they satisfied prerequisites? Well, satisfied prerequisites is arguably related to the course. Paid up is not particularly related to the course in the context of a full-time student. It's a generic thing that applies to all courses. If those attributes cannot be reasonably put together as a single compound attribute, then almost certainly you are better to have a separate third entity. Again, whether or not that separate third entity winds up being two separate binary relationships, or whether it is, as is the case here, the notion of the single entity relationship, the single relationship among the three entities, that is to some degree a separate design decision. Okay. Binary versus n-ary relationships. Now, this is where the textbook again basically says binary relationships are always better. N-ary relationships are not to be preferred, they're to be dispreferred, etc. I'm sorry, but I totally disagree with the textbook on this. But, first of all, let's deal with some mechanics. Any n-ary relation, in principle, can be replaced by n times n minus 1 over 2 binary relationships. If the relationship is inherently an n-ary one, this should not be done. An n-ary relationship shows that the entities participate in a single action. So, a person signs out a book from a library. 3 separate things. A company purchases parts from a supplier. 3 separate entities. They should all be connected in a single offering. A session is offered in a classroom at a time for a course. 4 separate entities. Okay? N-ary relationship enforces that the entities are in a single relationship. If that is broken down into a series of binary relationships, the only enforcement that is possible is if you add that enforcement by other means. This is folly. You are going to forget to do it. You are going to skip doing it. You will wind up having errors in your database because of it. In the case of courses, for example, you'll have sessions that are scheduled at times when when it's scheduled for a classroom, and other sessions are scheduled at the same time in the same classroom. You need to connect the things together. That said, beware of apparently non-binary relationships. So take the relationship parents. It relates a child to his, her, father, or mother. sounds like a natural ternary relationship. A child has a father and a mother. That might in fact be better replaced by separate binary relations. Why? Because we can have partial information. Unlike the situation of a course that's scheduled in a classroom at a given time, which has to go together, otherwise we've got double booking, not knowing who the father or the mother are, not an issue. You may only know the mother, in which case requiring father information is a problem. Conversely, the relationship between the father and the mother may be also not necessary to know or not even known. Okay? So, in cases where it's not necessary and information might be missing, binary relationships may be preferable. Okay? So, again, session, classroom, time slot, probably a single ternary relation offering, and almost certainly that captures the missing classroom time slot relation because classrooms are busy during certain time slots, and that should all probably be a weak entity aggregation to course. And we will talk about what an aggregation is very shortly. Before we do, I want to talk about specialization and generalization. And if you've done anything in object-oriented and inheritance, this will be a fairly natural concept. So consider undergraduate students at Waterloo. They all have an address, they all have a degree program, they all have ... name, grades, first name, last name, email address, whatever. Now consider the engineering undergraduate students. They all have a co-op program, they have this thing called WOP-PD, they may have other things that are specific to engineering. Now let's consider undergraduate electrical and computer engineering students. They have all of the things that students have, and all of the things that engineering students have, and they are required to do a technical presentation, they are required to they are required to complete 2 ECE-specific natural science electives, etc. Going down, progressive specialization. Going up, progressive generalization. These two are just different names for the same thing. Broadly speaking, there is the concept of what is called attribute inheritance, which is the inheritance of attributes of the higher level entity set. So this is an entity set, engineering undergraduates. This is an entity set, undergraduates. The engineering undergraduates inherit every attribute that the undergraduates have. The ECE undergraduates inherit every attribute that the engineering undergraduates have. How do we illustrate this? Okay. 2 separate concepts. Total versus partial generalization, overlapping versus disjoint generalization. So we'll deal with total versus partial. Total generalization. All persons are employees or students or both. Partial generalization. A person may be neither an employee nor a student. There is no well-defined notation for this. There is no generally accepted notation for this. It is worth spelling out whether or not in any given specialization or generalization, the generalization is total or partial because it makes a difference. If it is partial, then there will be people who are not employees or students. There will be employees who are not instructors or secretaries. Okay? If it is total, there will be no person who is not an employee or a student. And this is important because it basically amounts to, is there information here for which there is no additional information here? In fact, if you think about it, a very good example of this is every person has names, and middle names are a partial generalization of names. Okay, that's with respect to attributes in particular. Not everybody has middle names. Okay, overlapping versus disjoint generalization. Overlapping generalization, a person could be an employee or a student or both. This is illustrated by disconnected arrows. Disjoint generalization says a person must be, or if they are in this category, again, depends whether it's partial or total generalization, but if they are in this subcategory, they are either an instructor or a secretary. They are not both. So that's disjoint generalization. These are orthogonal issues, and you will need to specify both in the context of any ER model you do. These overlapping and disjoint can be specified by diagrams. Total versus partial, you need to specify within the text associated document of an entity relationship model. Okay, the final portion. Relation to relation relationships. Whoa, that's an interesting thing. Let us suppose we consider this project instructor-student situation that we had earlier. Instructors guide students doing projects. And so we have this ternary relation that connects the three things together. We want to evaluate these in an ongoing basis, okay? So there's an evaluation entity, maybe there's a pre-project evaluation and a kickoff evaluation and various intermediate evaluations, maybe yearly evaluations, and then at the end of the project there's a summary evaluation. Now technically, this evaluation is a quaternary relation between the evaluation entity and the instructor, the student, and the project. But what it really is it's an evaluation of the project guidance relationship. We want to evaluate this. We want to connect a relationship to another relationship. At the moment, all our relationships are between two entities. Instead, we want an entity to relationship relation, or an entity, or a relationship to relationship entity. This, you could imagine itself, instead of being a thing, being a relationship between entities. The technique for doing this is called aggregation. Aggregation allows us to express a relationship between an entity or another aggregation and the relationship that forms the aggregation. So, relationships, evaluation, and project guide represent overlapping information. How are they overlapping information? Well, project guide connects this, this, and this together. Evaluation connects these three, which are already connected by this, and the evaluation entity. So the evaluation relationship is a superset of the project guide relationship in some sense. However, we cannot discard the project guide relationship. Why not? Well, first of all, the project guide relationship exists in the absence of any evaluation. In fact, the project guidance relationship may simply be a declaration of the existence of the project between the instructor, the students involved, and the project. Might describe the proposal documents, etc. The evaluation will have, it obviously needs to connect to the project, but it will occur multiple times, and the different additional attributes, the additional attributes will generally be different. the cardinalities are likely to be different too. Okay, aggregation, we're going to treat the entire relationship as an abstract entity. This removes redundancy, and it allows relationships between, as I said, entities and other relationships, or between relationships and relationships. So we need to determine what's the primary key of an aggregation, and what's the primary key of the relation that connects the aggregation to either another aggregation, in a relationship-to-relationship case, or another entity, as in the previous case. So we'll talk about the diagram and the primary keys. Diagrammatically, we place an outer rectangle around the relationship. This expresses it as an aggregation. We then connect the relationship to that rectangle. And the other entity, which may be itself an aggregation or may be a separate entity alone, as is the case here, is then connected to that relationship. And there could, of course, be other entities or even other aggregation entities. Okay. What is the primary key of an aggregation? So what is the primary key of this thing? Not of this thing, but of this thing. The primary key of this is the primary key of this relationship. That's it. That's all that's required. So, dead easy to compute because you've already computed it here. What is the primary key of the aggregation relation? So what's the primary key of eval 4? The primary key of the aggregation is determined exactly the same way as we determine the primary key of any other relation between entities. A superkey is the primary key of the two entities involved, so the primary key for this aggregation and the primary key of this evaluation will be the starting point of the primary key for this relation. Then to determine whether the primary key, that would be the superkey, to determine whether the primary key can be less than that will depend on the cardinalities between the entities or aggregate entities involved. That concludes the entity relationship modeling aspect of entity relationship. The next video lecture will be all about how do we convert entity relationship models into relationship-only models. Because we have a relational database, we do not have an entity relational database. So we need to convert it to relational models in order to be able to implement it on a relational database.